we are started. What up, athletes? Whoop, whoop. All right, let's do this. Today is finding theta. So what we've been doing is we've been using our given angle or our theta. We've been using sine, cosine, and tangent to then find missing legs. Now we're going to go backwards with that. We're actually going to take our given legs and we're going to use that to find a missing angle. So how do we do that? I'm glad you asked. We're going to use arc sine, arc tangent, and arc cosine, also known as the inverse sine, inverse tangent, inverse cosine. All right, which on a calculator, if you look right here, if you look above the sign, it says sine to the -1. That's what it means. It's the inverse, right? So you'll hit second function that, or whatever is different on your calculator. But let's set it up and talk about it. It says find the angle of measure from the boy to the top of the tree around your answer to the nearest hundredth. So now I want to find this angle. I want to find out what theta is. Now I'm going to go about the same process that we've been doing with our tangent packet and then with our SOHCAHTOA packet. I'm going to identify what do I have here. Well, first of all, I have my opposite, right? And I have my adjacent leg. Which one of those has opposite over adjacent? Well, maybe before we do that, we write it down. SOHCAHTOA. Good times. Which one is opposite over or opposite adjacent? Well, tangent is. So I know that the tangent of theta is equal to my opposite over adjacent, which is 28 over 40. Now, if I want to find out what theta is, guess what? If I take the inverse tangent, so that's tangent to the -1, or the arctangent of 28 over 40, it will equal theta. And the reason I know that is I want you guys to see this. So inverse tangent cancels out tangent, all right? So let me show you just kind of a little exercise. If I take, let's say, the tangent of 38 degrees, right? Tangent of, or let's say 45 degrees. Boom. That's 1. So watch this now. I'm going to take the inverse tangent of the tangent of 45 degrees. If I did this correctly, it should come out as 45 because the inverse tangent should cancel out the tangent. We should just be left with 45 degrees. Look at that, it's 45 degrees. So when you take the inverse tangent, it undoes the tangent function and brings you back to the degree measure. So now we're going to do that with second function inverse tangent of 28 divided by 40. It is important now to put that closing bracket. If you're just taking the tangent of something, that really doesn't matter, but because we're doing division, we need that division included in the bracket. Make sure you do that. And let's find out. So it tells us, by the way, to round our answers to the nearest hundredth, and this is approximately 34.99 degrees. So our theta is approximately 34.99 degrees. Make sure you put that degree symbol, right? And that's our answer, and that's what we're doing today. So let's go ahead and try another one. All right, find the measure of a to the nearest degree. Okay, well, it's hard to see a little bit, but this is my a right here, which means I have an adjacent leg. I don't have an opposite leg, but what I do have is a what? A hypotenuse. If you're ever curious about how we know it's a hypotenuse, remember, it's always opposite of the 90-degree angle. Okay? So which one has adjacent and hypotenuse? See, that's opposite over hypotenuse. That's adjacent over hypotenuse. Cosine. So I know that the cosine of theta is equal to my adjacent, which is 13, over my hypotenuse, which is 20. Therefore, my theta is going to equal the inverse cosine of 13 over 20. It's really that simple. That's what we're going at today. So we're going to have second function, inverse cosine of 13 divided by 20. Close off that bracket. And this one says to round to the nearest degree, which is going to be 49.4, so just 49 degrees. So this is approximately 49 degrees. Perfect. And I would encourage you guys, make sure you're reading all the way through these because they're going to tell you nearest degrees sometimes, right? Another shout out to Mrs. Davenport, as for your second page, she gave you all these nice little examples just to look at as you work through the second page. We're going to be solving for a lot of theta today. So that's really about it. It's not a long lesson. It's just more of the same. There are some more practice using sine and cosine and tangent to find missing legs as well. So you just got to identify what it is you're looking for and keep practicing and plugging the way through. All right, you ready? Peace out.